So we would like to find the directional derivative of the function f of xy equals x squared y minus y plus 1 at the point 1, 2 in the direction of the vector 1 over square root of 2 and negative 1 over square root of 2. And let's recall what is involved here. So first of all, what is the notation for this directional derivative? This will be d sub with a subscript for the vector of f at 1, 2. And that's equal to this vector that we call the gradient, and we'll say in a second what this is, dot product with the direction vector. Okay, so what is the gradient? The gradient, simply speaking, is the vector whose components, whose coordinates, are the partial derivatives at the given point. At first, it seems like an artificial vector, but its use is not just to find the rate of change or the directional derivative, but there are so many other things. So in general, I could give the general formula as the directional derivative of f at the point a, b in the direction of the vector u is simply the gradient of the function at that point dot with u. This is really the formula that we use in this case. This is what we need to know. So I think having said all that, it should be pretty straightforward to solve this problem. So how do we solve it? Start by finding the derivatives. So f sub x is equal to 2x y, which means that f sub x is going to be at 1, 2 is going to be equal to 4. And f sub y is equal to x squared minus 1. So f sub y at 1, 2 is equal to 1 squared minus 1, also known as 0. So the gradient of f at the point 1, 2 is simply the vector 4, 0, which means that the directional derivative in the direction of the vector 1 over square root of 2, negative 1 over square root of 2 of f at the point 1/2 is going to be the gradient of f at 1, I'm sorry, not 1/2, 1, 2 times, or dot, I should say, 1 over square root of 2, negative 1 over square root of 2, which is equal to 4, 0 dot 1 over square root of 2, negative 1 over square root of 2. And this, of course, is 4 over square root of 2. Okay, there's no need to do a cancellation here, but if one wants to do a cancellation, this is simply 2 square root of 2. And that's all. That means that if you move, if you're on the graph of f, and we move at the point 1, 2 in the direction of that vector, 1 over square root of 2, negative 1 over square root of 2, so this is something like this, then the rate of change that we will experience is 2 square root of 2. And that's all. Thanks for watching.